Okay, in this video we're going to talk about how to calculate several probabilities when we're given a table like this one. So we have a study of the relationship between liver health and alcohol drinking status. A large group of participants were asked a series of questions and underwent an exam to judge the health of their liver. Okay, so we have unhealthy liver and never, sometimes, often drink. All right, and so we're going to calculate some probabilities. First one that we're going to calculate is the probability of N, or the probability of never drinking. Okay, I just want to let you guys know I do have a dog squeaking a toy in my background. Sorry, hopefully it's not too distracting. She's a puppy and cannot be stopped. So, all right. So, starting with the probability of never drinking. So what we would do to calculate this is we'd say, okay, well, how many people in this group never drink? And so we see here it's already added up for us. 640 never drink out of the 2912 in the group, right? This is the total number of people that participated in this study. Okay, so that one's nice and easy. All right, so moving on to something that might be a little bit more difficult. What about calculating the probability of H? And then there's this little mark prime next to it. First off, you need to know, what does that mean? Well, H is the that the selected participant has a healthy liver. So this little mark means not H, right? Sometimes people use like a bar over top to note not, right? So this means the complement of H. So the way we could figure this out is, well, we could do 1 minus the probability of H, okay? And so this would be 1 minus, let's see, the probability of H, how many people have a healthy liver, total number of people with healthy livers, 1611, okay, 1611 over 2912, all right, and then you could do this, actually, because there's only one other group, unhealthy liver, this should come out to be 1301 divided by 2912. All right, so now let's go ahead and move on to one that's even more difficult. What about something if you see it like this? N, and then there's this intersection symbol, H. Okay, first you need to know what intersection means. Intersection, remember if you had like the Venn diagrams, this area in here is the intersection. Okay, so this is N and this is H. That area there is the intersection. So it's and, right? So where we have never drank and healthy liver, right? That's what we're looking for right now. So never drinks. Okay, here's never drinks and healthy liver. Okay, how many people meet that criteria? We got a whopping 530 people out of the entire group. 2912. Okay, so 2912. So 530 out of 2912. That would be the probability of never drinks and has healthy liver. All right. So now if we did and, now next let's think about or. So the probability of N union H, right? So the probability of never drinks or healthy liver, right? So if you were to do this, you could use the formula, which is the addition formula. So never drinks plus the probability of healthy liver, and then subtract out the never drinks and healthy liver. Okay, what's going on with this formula? This piece here on your little Venn diagram, it's all of this, right? And this red piece over here, sorry, this piece here is all of this. So you see how that yellow piece got added in twice? So that's why we subtract it off. That's why we do this minus the intersection, right? So we subtract off that piece. The green and the red Yellow got added in twice, so we subtracted it off, right? So let's see, we could go ahead, the probability of, we already found all of these pieces. 640 divided by 2912, that was never drinks. Healthy liver, we found it right there. 1611 divided by 2912, and then we'd subtract off the intersection. We found that right here. 530 divided by 2912. Let's see. Go ahead and do those numerators. So plug that into my calculator. 640 plus 1611 minus 530. We're looking at 1721 divided by 2912. Okay, so that's some, okay, so that, that was using the formula. Of course, you don't have to use the formula when you have a table like this. Like, you're given all the information. So they asked the probability of never drinks or has a healthy liver. Okay, so if you meet either one of those criterias, you should be counted. So let's see, never drinks, these people should be counted. These people should be counted because they never drink. Healthy liver, again, these people should be counted. These people should be counted. These people should be counted. If you add up these ones I just did in blue, these are ones that are meeting one criteria or the other, and that should add up to 1712. Okay? All right, let's see. Let's do one more like this. What if we were asked the probability of never drinks given that you have a healthy liver? Okay, so you are not part of this entire group of people, right? It's given that you have a healthy liver, so you are one of these people, okay? So it's given that you have a healthy liver, you belong to this group that I just circled in red. All right, so what's the probability of never drinking in this group I just circled? Well, there's 530 people who never drink in that group, right? So 530 out of how many people total are in that group? 1611. All right, 1611. So there you go. That's that conditional probability. Of course, you could have used the formula for this, which would be the probability of never drinks and healthy liver divided by the probability of healthy liver, right? This is the Bayes formula, or the formula for conditional probability, and so we already calculated each of these pieces. So never drinks and healthy liver, this is up here, 530 divided by 2912, and then healthy liver, there it is, 1611 divided by 2912. If you remember your how to deal with complex fractions, you got fraction over fraction, you got to take that one fraction that's on the bottom and you got to flip it, right? So multiply by the reciprocal. And so what happens? These guys cancel, and you end up with 530 divided by 1611, same answer we got using logic, right?